So a little 80s music there called Pump Up the Volume, appropriate for what we're going to be talking about. I asked on the board at school to make sure that you take some brief notes as you watch this video. I promise to keep it short, and hopefully most of it is review for you. We're going to be talking about volume of three specific shapes, and that is a cylinder, a cone, and a sphere. A lot of this will be a review of something that you've seen before, but it is essential that I go over it before we do our activity in class tomorrow. So, we spent a little bit of time already in Chapter 1 talking about area, and we're going to move from area now to volume, and it's really kind of the natural move that you make in mathematics because you're going from what was two-dimensional to what is now three-dimensional. So we're just adding a dimension to area and giving ourselves volume. We're talking about taking up volumes of space now versus just taking up a plain area. One thing you have to be careful of is your units. You know that units are squared in 2 dimensions. Units are cubed in three dimensions. So when doing the activity tomorrow, pay attention to the units that you're working with. In general, I hope you remember that we usually talk about volume as some length times width times height. That's the easiest way of thinking of volume. And for most figures that you've dealt with, this length times width is actually just the base of the figure. So we often say that volume is base times height because length times width is just the base. The three volumes that we're going to be dealing with all involve circles. So I want to do just a quick little bit of review of some things that you know about circles. There are 2 major formulas that you must know. That is the area formula, and we know that to be pi r squared. The other is the circumference of a circle, the outside perimeter of a circle. C is equal to 2 pi r, where pi, the number that we'll be using, is the approximation of 3.14, and r is the radius. All right, so hopefully if you have all that down, you can go on to the next page. All right, so let's take a second and talk about our friend here, the cylinder. All right, so I've given you a picture of a cylinder, and I've identified the 2 key pieces that we'll be dealing with, and that is the height h and the radius r, and that's where they're located. Again, very easily measured things. If you had a ruler or a tape measure, you could measure those things. And like I said on the previous page, volume of a cylinder is easily found by taking its base and multiplying it times its height. And by base, I mean this circular piece down here. Well, it's a circle, and we know the area of a circle. That is pi r squared times h, which is the height, and that ends up being the volume of a cylinder. So maybe one way that's easy for you to remember is that the volume of a cylinder is really the area of a circle times the height. So that's why pi r squared times h is the volume formula that you're going to need to know for any cylinder. The next volume that we need to talk about is that of a cone. And again, notice in the picture here that the base of a cone is really just a circle. And really, a lot of people look at cones as kind of tapered cylinders, that if we were to kind of extend the base of the cone up, that we would actually have a cylinder. So it's not going to be shocking to see that the volume of a cone is related to that of the volume of a cylinder, because it is just kind of a tapered cylinder. It ends up that a cone is actually just a fractional part of its cylinder that makes it up. And in fact, the fractional part is that it's 1/3 of it. So the volume of a cone is 1/3 the volume of the cylinder that it is part of. And we know that the volume of a cylinder is the area of the circle for its base times its height. So we would say 1/3 pi r squared h. Again, where this pi r squared h is just that volume for the cylinder, and then we're taking a third of it because it's just tapered. So that's going to be another formula you're going to need to know for class tomorrow. And again, the height and the radius of a cylinder are not hard to find if you have some measurement devices that will allow you to do so. All right, the final volume that we'll be dealing with tomorrow is that of a sphere. And spheres are kind of unique in terms of the world of volumes in that there is no base for a sphere. Whereas we said that it's base times height for most volumes, a sphere kind of has this circular disc in the middle of it as is represented here. Let me darken that in for you. This circular disc which defines its center. But it then just kind of changes sizes, this disc, as you move it down in the sphere, but there's no actual base. You never get to a point where there's something that you're starting with. It kind of vanishes off to an infinitely small value. So we can't use the same formula. And one of the things that you should know about a sphere is clearly it's still based in circles. So it's going to be a circle-based formula. This one would be a little harder to try to explain to you where it's actually derived from, but one of the things that I hope you see is that the thing that is really determining the volume, the size of the space that's being taken up for in a sphere, is its radius. That the bigger that radius is, the bigger the volume will be. The smaller the radius, the smaller the volume. So volume is a function of radius length. And in fact, I can go as far as to say that it's actually only a function of radius length. Okay, it has nothing to do with height, because really, if you considered height, if I drew in some height of this circle, that height is actually a radius. So we wouldn't want to confuse you and start calling a radius an h or a diameter 2h. That we'll stick with just dealing with things in terms of the radius. So the formula that you'll need to know for the sphere is that the volume of a sphere is 4/3 pi r cubed. And again, like I said, the derivation of that one is not so easy, so I'm not going to really deal with that in this particular video, but this will be the formula that we'll be dealing with for a cube. For a sphere. The last thing is, in terms of a sphere, it's really hard to measure the radius. I mean, think of trying to measure the radius of a basketball or of some other solid spherical object. You can't really, slice it open and measure to its center. So we have to have different ways of finding the radius, and that's where one of our other area formulas comes into play. Not area formula, circumference formula for a circle. We had said on the previous page that the circumference is 2 pi r. And circumference is outside measurement, the measurement of the perimeter of a circle. So we can actually solve this for r by dividing each side by 2 pi. Those cancel on that side, and you get that r is the ratio of the circumference to 2 pi. And that is a very usable piece of information because I can find the circumference of a sphere. I can measure along the outside of the sphere, find its largest distance around the outside, and use that as its circumference. So C is largest distance around the sphere. So, given a tape measure or a string, I can find that largest distance, use that as my circumference, and divide that by 2 pi to find the radius. Alright, so knowing that the volume is 4/3 pi r cubed is one of the pieces of information you'll need to know for tomorrow, and also being able to find that radius of a solid sphere without destroying whatever it is that you're trying to measure to find its volume. Okay, those are the 3 formulas you need for cylinders, cones, and spheres. Make sure you have this stuff written down. Bring it with you tomorrow. You'll be able to use it during the activity. All right, thanks for watching. I'll see you in class.